Here at Our Sci, we're on a mission to develop a data pipeline that turns many sparse sources of complex data into directly useful information covering the whole path from the field to prediction outputs. Data source. The journey begins when a real-world object, such as a piece of produce, is selected for evaluation. We gather information about this object from several sources: the farmers themselves, our labs, and even external data sources like climate APIs. Survey stack, data entry instruments. We compile this data using Survey Stack, a powerful survey design tool that allows us to design specific input instruments for each need. Some of our projects merge as many as 10 surveys to get a full profile of each sample. As a data point travels through our system, we continually check the quality of the gathered information using QA dashboards. Information then gets stored in a database and can be easily accessed through an automated query generator. This simplifies both insulating private data and sharing or open sourcing valuable research in a safe, controlled way. Quality control. The data pipeline seeks out information about each particular point through all surveys and forms a single entry containing everything we know about it. It works continuously, which allows us to glimpse the current state of the database at any given moment. Consolidation and output. At the moment of merging, data gets organized into column-based tables. This is the preferred format for Excel, but also for Python and R, allowing advanced data science treatments or any other research. The merging is declarative. It's enough to fill some parameters into the system to get to work. The next step in our process is analysis, which is the most complicated procedure, but also the most important for a quality, flexible data set. We find and remove errors and outliers in order to produce dependable insights. Cleaned data is represented in several kinds of visualizations. Well-designed plots let us focus on relevant details faster. Sharing with users and investigators. We use data dashboards to share the information we've gathered back to the community. They allow users to test their own hypothesis by visually comparing different points that are relevant to them. When everyone has access to this information, we gain different perspectives, which in turn give us better insights and new areas of exploration. Modeling and in-field prediction. One of our main tasks is modeling, which lets us reliably predict information that is otherwise hard or expensive to measure. We are currently training ensemble models, such as quantile random forests, and also applying testing procedures, for example, nonparametric median comparisons. We can then make predictions based on the results of our models, from determining soil carbon to details of a crop's nutritional value. Our infrastructure allows us to offer the models to end users via an API so they can apply predictions on the field. At this stage of the process, we might say that the original data point is still directly involved. It's what informs the model, allowing us to better understand what exists in the real world. What's so unique and exciting about this system is its integration, how we can move from research to prediction in the same platform, following a single data point all the way through. Thank you for joining us. And if you have a question or a new idea, please contact us. We'd love to give it a try.